Okay, so this is problem 4.32 out of Taylor's Mechanics. And it's based off of this picture here. And what we want to do is first prove that the bead's speed is just s dot. After that, we want to prove that ms double dot is the tangential part of our force. And they give us a little hint on how to do that. And then lastly, we want to prove that our tangential force is just minus du ds. Okay, so let's go ahead with this. Our velocity v can be written as dx dt, dy dt, dz dt. And the speed, which is just the magnitude, is dx dt squared plus dy dt squared plus dz dt squared, all square root. And even though it's not actually a fraction, it does end up working out this way, that we can write it as dx squared, dy squared, dz squared, square root all over dt. And we define ds as dx plus dy plus dz. So this then is just the square root of ds squared, or just ds dt, which is equal to s dot. So the speed is equal to s dot. So that part's taken care of. The next part, and they give us a hint here of how to work with it by saying that v squared is equal to v dot v. And if you take a time derivative of both sides, what do we get? Well, the 2 comes down, and it's a chain rule because we're taking a derivative with respect to t. That is going to be that one side on the right. I don't know why I did it the other way, but I did. And what we want to know, or what we want to do here, is make note of the fact that mv dot is equal to f tan, and we can solve and see that v dot is f tan over m. I have a bit of a messed up screen, so I have to write on one side for right now. So what we can do, I'm sorry, one of these should have been v dot as well. Okay. So now what we can do is substitute this into here. Or, better yet, into here. Doesn't really matter. So what do we get? 2v v dot equals 2v dot f tan over m. You can see that the 2 v's cancel. And what are we left with? mv dot equals f tan. And we know that v, we just saw v is equal to s dot. So v dot is ms double dot. Okay, so that's taken care of. The last thing we need to do here is, what do they want? They want us to show that f tan is minus du ds. Okay. So they mentioned that there's a normal force minus our conservative forces. So we'll say normal minus, and then we can just write, since they're conservative, the gradient of u. Okay. Now, if we want the tangential part of our force, let's see if I can draw this. Notice that the normal force is always perpendicular to, you could say, s, the direction that we're traveling. So then, when we're looking at f tangent, we don't need to worry about the normal. It's just minus grad u. Okay? And The gradient tells us to take our spatial derivatives, but our spatial derivative here is ds. So then f tan is minus du ds.